As Rosalind actually introduced, my name is Sam from School of Mechanical Engineering. I'll be talking about project-based learning in teaching first year design and manufacture course. It's not a one-man show. I think Richard actually already put that down, the first thing, spot on resources. That's a key issue. So I wasn't the only one actually. Myself and Philip, in fact, I've taken over from Philip in 2001. Somewhere around that. And the first year course, huge class, and the first reaction I got was they said actually usually in schools, large classes, first year teaching actually given to, newcomers. Here you go, you enjoy it. And then of course, Belinda has been instrumental since the beginning of this course. Ian McAlpine, he left, but actually he contributed quite a bit. Carol has been part of it as a faculty teaching and learning fellow. And we have another lecturer, he involved in the last part of the course. Let me give you a bit of a background information, what the course is all about. It's been running forever as far as I know. The customers have been changing. We used to get students from Faculty of Built Environment, Industrial Design. They dropped out, they decided to teach themselves, but they still come and nag us when they have questions related to manufacturability of their designs. Currently, it's a first year course. It's open to actually all engineering schools, so it's a common course. Since 2007, we've started running session 1 and session 2. Before that, it was only session 2. And this semester, so this year, semester 1, we had 72 enrollments. And this semester, we had 240 enrollments. It could have been worse. We had to shut down the enrollments because of some logistics reasons. We couldn't handle anything more than that. What's the course content? We are supposed to teach them, by the way, bear in mind that these students turn up. They don't know anything about CAD. They don't know anything about engineering drawing. They don't know anything about manufacturing. In fact, some of them actually can and have injured themselves with screwdrivers. Okay, that bad, okay? And they are the students that we are getting, and the challenge is actually turn them into an engineering or CAD engineering students. So we are supposed to teach them actually a CAD package, in this case, CATIA, engineering drawing as a communication language. We need to teach them actually manufacturing technologies, at least relevant ones. And we have the hands-on TAFE training. We send them actually to TAFE in Ultimo. And it's actually one of the things that we introduced. They get a certification for hands and power tools training so that when they turn up second or third year or fourth year in our labs, we can rely on, at least they have a certification, will be safe. They go through various trainings, measuring, fitting, milling, turning. What was the old strategy? I'm talking about pre-2002. 2 hours face-to-face teaching, large class in lecture theater, very little interaction. One of the biggest trouble was actually the lecture was, or the course was disjointed. Okay, they used to do graphics in CAD labs, teaching in one classroom. They go to TAFE. They didn't even understand what's the relation. And that actually brought back memories. When I graduated as a graduate engineer, got my first job, and my boss actually gave me a problem. And I looked at the problem. It didn't say it's a fluid problem, or a thermo problem, or it's a mechanics of solids problem. So I was supposed to actually bring in all those knowledge that I have acquired to address that problem, and I didn't have that skill. And we implicitly assume that actually we have that skill, or the students actually will be developing that skill by the time they graduate. And they had the similar problem. So what was the outcome? That's a literal, actually, student feedback from a CATI form. Math is boring, physics is boring, but this course is that boring. Okay, I'm just using their terms so that you can actually appreciate their frankness, which is quite nice. We started actually developing this course in 2002. We applied for a faculty teaching and learning grant, and I put that sort of plan do checked act sort of circles. And it hasn't finished yet. Probably it's going to evolve. Hopefully it doesn't actually turn into a tornado at some stage, but it's actually, we completed the first stage. We are almost actually completing the second stage, and probably we're going to go to the third stage, keep improving. The first stage was, we have this huge textbook. It's like a Bible of manufacturing technologies. Students don't read. That's my own experience. You give them so many materials, but they don't read. We decided to actually develop... Is it? Okay. We decided to develop actually online course materials, make it actually a bit more exciting, singing, dancing web pages so that they can at least watch and learn what it is. And then in the second stage, probably back then we didn't think about it, to be honest, but we decided to introduce actually project-based learning to integrate all of those components. So the first part turned out to be actually, in fact, a resource, not actually teaching itself. So let's start from the first one. What we were expecting, actually creating some self-learning modules, web-based animations, video clips. We are expecting that students actually will learn on their own pace. And the web-based reviews, examinations, and it took actually quite a lot of time. We started with a plan, a pilot project, different manufacturing groups, processes. We had this nice flow chart, visualize, simulate, pattern designs. We developed assessments, all of those things. Thanks to back then EdTech people, we developed these. This is an old WebCT web page, of course, nice web pages around this particular layout. Okay, we had the description of the process, very simple description of the process, a video clip. Bear in mind that, as I said before, if they don't know what the screwdriver is, it's quite like that they don't know anything about manufacturing processes. And just by looking at a picture in a textbook, they wouldn't appreciate. So we had to actually create these small video clips. Video clip doesn't show you what happens actually inside the process. So we had to actually animate what happens as far as the process is concerned. In addition, we added actually references and some, if they want to jump from one page to another page, we added actually some sort of control features so that they can go through. We also developed online quizzes to let them actually self-assess how they are doing. I think it took about, how long? 2 years, 3 years? We are talking about hundreds of actually manufacturing processes, okay, translated into these kind of web pages. Of course, we regularly check how we are progressing, student surveys, cat eyes. 70% said actually, it's very nice, no problem. But they said not as a course, as an additional resource. And it's not it shouldn't be used to replace face-to-face lecturing. And frankly, that was another, still boring. The reason being why it's still boring is that we've developed all of those materials, but it was actually in the one component of the course. So the course actually was still disjointed. And it was 2006. We started thinking about, I had a long chat with Philip. I said, this is not working. Let's change it. We start from scratch. What is it that we are expecting? What is it that we are expecting from these students to learn as a learning outcome of this course? We don't want them to learn every possible manufacturing processes because they won't be operators. We want them to appreciate the link between actually designing a product and the manufacturing the product. So that was actually the starting point. Some people don't believe that you can use actually your research in teaching, but we used actually a concept called concurrent product and process development. I did my PhD on that topic. And when I was working in industry, we used to actually engage for developing products. So we said, how about if we actually integrate those courses or those components around a product development project, an actual product development project. It was a challenge, given that their background, they don't know anything about product development, so it's going to be a challenge. I I decided to actually design a pump. Very, very simple pump. I designed it myself, built it, have a prototype, but it was actually an actual working product. It wasn't a teaching and learning object yet. So I had to spend about, I think it took about 7 months to turn that simple pump into a teaching and learning objects. I had to separate each component, make sure there are 5 components, 5 group members. Each of them actually allocate the one component, and they are responsible from design to finish all the way. Okay, that was the idea. So how does it work? We give them a functional specifications. What it means is that if you're not coming from engineering or product development background, 1 page, rough description of actually what the product should do from the customer perspective. It's very wishy-washy. So what we do, we expect them actually to develop a pump at the end. This is actually on the YouTube. Students actually put that on. When I first showed this on the introduction lectures, they can't believe it. They said, no, it can't be done. In 11 or 12 weeks, coming from that to that. But in between, what we do, we ask them to develop a concept sketch. Their imagination of actually how they perceive that pump is going to look like. And then we ask them to develop detailed engineering drawings, which is manufacturable out of that concept sketch. Once they develop that, we ask them to actually develop a production plan, how they intend to make it, step by step. And they go to TAFE and manufacture it. Hopefully, at the end, they'll have a pump. Now, we actually expect them to realize the lack of skills. So, for instance, when we ask them to develop a concept sketch skill, they said, hang on a sec, we don't know anything about concept sketch. Then let's talk about concept sketch. And we explain how it works. And then when it comes to engineering drawing, they don't know anything about it. We start teaching CAD skills. Manufacturing skills, how the production planning needs to be actually put together. And of course, workshop skills. As far as the assessments are concerned, we had to actually start all over from the scratch. In order to mimic exactly what happens in industry so that it becomes actually relevant, I literally copied across what's done in industry to classroom. So we don't have any exams. What you have if you worked for a company, especially a project-based company, you get a tender from a customer, you design a product, and you go through a series of reviews. You start with a concept sketch review, that's first assessment, and we have a design review. We sit down with the groups of students and then discuss actually how they are doing. And then the next stage, we have a process review based on that design, whether or not actually that's manufacturable, their process plan. And we have a product review, actual testing of the component or the product at the end of the semester. We are going to have one, Week 12, Monday. You're more than welcome to join, 48 groups. We don't know how we're going to handle it, but it's going to be a logistic challenge. Now, this project is carried out in groups of 5, okay? So every student is actually responsible from one component, as I said before. In that sense, I'm not concerned about the contributions. I'm not concerned about the peer review, because if they don't do it, at every stage, I know who hasn't done the work, because that component is missing all the way to the end. So in that sense, it's working nicely. I don't have to actually worry about it. In fact, this is actually a pump. We started implementing this 2007 first semester. It turned out to be so popular. There's a gentleman, Graham Payton. Apparently, he made actually so much money than he can spend. So he sort of donates money to these type of projects. When I talked to him, he loved the idea, and he actually put an award on the whole project. So we have a $400 for the first project, $200 for the second project, and the $100 for the third project. It's a good incentive. And this particular pump is the last year's winner. With that pump, they achieve actually 95% efficiency. That's absolutely incredible. For a group of students coming from a background they don't know anything about manufacturing and design. What's even more interesting, I separate them just to have fun. 50% hydraulic, we use water to test it. 50% pneumatic, we use air to test it. This pump actually worked as a hydraulic as well as pneumatic. Normally, there is no difference, but you need actually tighter tolerances for the pneumatic pump. So they are having fun. This is some of the student projects actually they built. You can have a look at it. They don't probably work properly now. I am. That's true. I'll get back to that. I am actually having more fun. We had to also develop right educational technologies. I think one of the biggest problems, as far as I can see, I've been involved in developing or using education technology since I joined university. There's a misuse, in fact, abuse of actually education technologies. You are not supposed to use education technology without getting the pedagogy right. You really need to actually, you shouldn't be animating something for just sake of actually animating it. It should actually serve a purpose. And in that context, we developed a project and we decided to put together a WebCT web page to communicate with the students, especially the big class numbers. We also decided to use WebCT to integrate. We have different course components as well as an external organization. So we had to give them an access to TAFE people so that they can upload all of their documents on a timely manner. So it actually made sort of our life very, very easy. Let me take you back to WebCT. Oh, cancel. Yeah. All right. This is how the WebCT page actually looks like. It's just ordinary. There's nothing special about it. Okay. Everything happens in the solar product development project. It's a name actually I made up, but the company is real. A company that I used to do consultancy. So. Okay, let's start again. No, not really. We carried over. We had some problems, especially the animations and all of those things. Some of the link didn't work, but thanks to guys from EdTech, I think we didn't have any problem from previous version of WebCT. Sorry, there are too many courses, so. Okay. So I tried to make it actually as realistic as possible. So I created a boardroom so they can get their first instructions. not just as a written piece of document. So, by the way, you realize that this is a good cell building room. What we did, we have a memo coming from a company, literally tells actually what they want. And I convinced our previous head of school, Hartmut, to shoot a video for us, explain to students actually what needs to be done. Design specifications coming from the company, and a solo web page, and a development guide for the students.
I have received a letter from a manufacturing company to request some assistance in
Can you hear?
the product development project. And
No.
I think this is an interesting project, so we should look into it and see what we can do for it. Therefore, let me briefly explain what the project is all about. The company's name is special applications. Currently, the company is fully occupied with the development of a new series of specialist pumps for the biomedical industry. And on top of that, they have received a request from another company to develop a new pump for mass production, but because their design department is fully loaded, they can't do it in-house, so they're considering outsourcing the product development process. Now, this process would be an excellent task for a product development team. The task of that team would be to develop a pump. The specifications will be provided. It is a small pneumatic pump. Then, to develop the production plan for that pump to be manufactured in large volume production, and then to build and test the prototype. The company has developed a certain approach to product development. They go through several stages, and after each stage they check the validity of the process. So in this case, after the first stage of computer-aided design, there will be a team scrutinizing the work, and then after the next step, the production plan, they will scrutinize it again, and then in the end, after the testing of the prototype, it will be another test. So it is an interesting project, and I believe we can do it. So let's start with it, and I wish you all good luck.
Okay, that's sort of just to make it a bit realistic, but what happened actually is that, and then we have a one-page memo, literally tells them step by step what's required or what pump actually is supposed to do. So it's the verbal description of actually what Hartmut was talking about in terms of actually what needs to be done so that they can go and repeat over and over again if they wanted to read. Once they get their first instructions, we have this project actually plan web page. So everything literally go through here. Week by week, from first week to week 12, it tells them what needs to be done. As you can see, all of these activities are overlapped. The concurrent product and process development name comes from that. They start with a project description. All of these hyperlinks link to all the documents that we have uploaded. What we go through here, review concept sketch, week 2, that's what they are supposed to do whenever there is a deliverables. Design review, process planning activities, process plan review, and then they go through manufacturing activities from week 9 to week 11. and then the product review, and then the feasibility report. What I didn't tell you, of course, is that what they are developing is just a prototype, proving that the principal concept works. It doesn't stop there. The functional specifications suggest that the company wants to make them 20,000 per year. So as it is, you can't really do it with the manufacturing process that they are using. So they need to go away and look into other high-volume manufacturing processes. That's where the actual individual learning takes place. They need to do a bit of research, and they need to come up with different manufacturing processes, cost comparison, and what will be the design implication. If they are using milling, you need a different component design versus if you are using injection molding. They must actually change their design, and they have to talk about it. You can't have sharp corners, you have to have taper angles and all of those things. And they submit a report at the end, feasibility report with the pump itself. Okay? And what we are talking about feasibility report, nothing more than starting from concept sketch, revised drawings, process plan, actual pump, and the cost calculation, the feasibility study at the end. Okay, that's what constitutes. If they keep doing from the day one, in fact, at the end, there's very little actually left to do. Everything that we developed hasn't been wasted. I can show you. I think we are running out of time. As I said before, we developed relevant actually course assessment to mimic real industry case studies. I've already talked about that. Outcomes. How did we do it? Even after first semester, the feedback was remarkable. I mean, they loved the whole idea. We had a lot of logistics problem. I'm not saying that actually we didn't have any negative feedback. They love giving negative feedback. But all of them were in the area of logistics organizational issues. For lecturers, Tim was right. Actually, it's very exciting and stimulating. Going through the semester is an administration nightmare, but the end is absolutely fun. I love it. For the school and faculty, actually it's very good because the demand for the course actually increased by about 30% since we introduced the course. This semester, we had to shut down the enrollment, and the next semester we decided to open 151st semester, 152nd semester. Otherwise, it's going to be unmanageable in terms of the logistics. Some of the student feedbacks, these are taken straight out of CATI forms that they've written. First, they do appreciate engineers' work, what they do, working in a team, effective, interesting, and then motivate me to learn and study more on my own, research on certain topics. I get this comment all the time, getting up 6:45, pain in the ass, but you know, it was definitely worth it. This is actually the last sentence clearly reflects what we want to achieve. Most of all, I learned that if you're going to make something, don't just assume that they will have parts and processes in the size that you want. So, again, I even managed to get actually a compliment at the end, just one. It's a great way of putting theory into practice. Okay, I learned how things can be made in industry and how proper planning and designing is essential to a working product. And probably this is the most valued feedback that I've ever received. The diversity of learning experience was the best aspect of this course, from tape workshop to computer labs, working together in small groups. Challenges were diverse but very stimulating. What next? We still have logistics problem. I think the switching from 14 weeks to 12 weeks didn't help either. So we had to start all over again, shorten, cut some of the sizes. We need to fine-tune some of those organizational issues. As it is, we have just one pump. I have already actually developed 2 more pumps, a peristaltic pump, a cantilever pumps. designed it. We are building 2 prototypes, and then hopefully I'll spend the rest of the semester turn them into learning objects, because some of the components doesn't require as much skill, so that needs to be made a little bit more complicated. Some of them needs to be simplified. But semester 1, 2009, there's going to be 3 products given. What I did, I designed the product in such a way that they have a similar displacement volume, so that at the end we can compare different products in terms of their efficiency. There's a web page or PDF, more detailed explanation. Belinda put that up on the UNILT web page. You can actually go and have a look at it.
We'll send that link out.
Yeah. But if you have any more questions, we can talk about it in terms of going back to that web page as well. Thank you. I've done my job.